Right, so here's an example. It's a nice word problem that we can model using a quadratic function. We'll use our quadratic function in vertex form. It says that the deck of the Lions Gate Bridge is suspended from two main cables attached to the tops of two supporting towers, so obviously one on each side of the bridge. Between the two towers, the main cables take the shape of a parabola as they support the weight of the deck. The towers are 111 meters tall relative to the water's surface and are 472 meters apart. Okay, so this is 111 meters. This is 472 meters. And the lowest point of the cables is approximately 67 meters above the water surface. Okay, so we want to model the shape of the cables with a quadratic function in vertex form. And the simplest quadratic function that we can draw is going to be the one that has its vertex at the origin. All right, so we're going to take that point, that's the lowest point in the cable, okay, and that's going to be where our vertex is. Okay, so that's going to be at the origin. I'll put that here. Okay, here we have our parabola going up from the origin. It looks like it's a bit above. I'm sorry about that. That's just my smartboard not being oriented properly. Okay, but we have our vertex. It's at 0, 0. Okay, now note, if that's going to be my x-axis right there, because I want to make a nice one that's easy to work with, it has the vertex at the origin. That means that my towers are 111 meters high, but if you take that x-axis and make that, you know, draw that line through the towers, that's going to be 67 meters. Okay, that's 67 meters. So we're going to split that 111, and it's going to be 67 meters below the x-axis, and then we're going to need another 43 meters above. Okay, so that means that when we have our towers, here our towers are going to be at these points. Okay, they're going to have a y coordinate of 43.